This video will cover the topic of hydrocarbons. Hydrocarbons are compounds that contain only carbon and hydrogen atoms. The majority of these are found naturally as crude oil. Hydrocarbons are classified into two main classes: saturated and unsaturated hydrocarbons. Saturated hydrocarbons are bonded by a single bond. Alkanes are an example, featuring a single bond as their functional group. Unsaturated hydrocarbons have carbon and carbon bonds that are more than single. Alkenes and alkenes are examples of unsaturated hydrocarbons. A homologous series is a group of carbon compounds related to each other. They share similar chemical reactions and the same general formula. Examples of homologous series include alkanes, alkenes, and alkynes. Alkanes are hydrocarbons that have a single bond as their functional group, making them saturated hydrocarbons. The two major sources of alkanes are natural gas, crude oil, and petroleum. The general formula for alkanes is CnH2n plus 2, where N is the number of carbon atoms and 2n plus 2 is the number of hydrogen atoms. For methane, where N equals 1, the molecular formula is CH4. This is the structure of methane. For ethane, with N equal to 2, the molecular formula is C2H6. This is the structure of ethane. For propane, where N equals 3, the molecular formula is C3H8. This is the structure of propane. For butane, with N equal to 4, the molecular formula is tetracarbon-decahydride. This is the structure of butane. The same formula is used for other alkanes, including pentane, hexane, heptane, octane, nonane, and decane. Regarding physical properties, solubility decreases as the molecular size of alkanes increases. Alkanes are generally insoluble in water. Melting and boiling points of alkanes increase with molecular size, and the density of alkanes also increases with molecular size. Intermolecular forces and the viscosity of alkanes increase with the molecular size of the alkane. This chart illustrates the melting and boiling points of alkanes. This chart illustrates the density of alkanes. Alkanes react with oxygen. Complete combustion forms carbon dioxide and water, as shown with methane reacting with oxygen. Incomplete combustion of alkanes forms carbon monoxide and water, as shown in this reaction with methane and oxygen. This is another example of incomplete combustion of methane forming carbon monoxide and water. Alkanes also undergo substitution reactions with halogens, such as the reaction between methane and chlorine. Cracking of alkanes is a process where a large hydrocarbon molecule breaks down into smaller, lighter, and more useful fragments. Catalytic cracking occurs at fairly lower temperatures, between 400 to 500 degrees Celsius, while larger alkanes are heated up to 700 degrees Celsius. For example, cracking dodecane produces hexene, butane, ethene, and hydrogen. This diagram illustrates the cracking process of an alkane or paraffin. Alkanes are used for making motor vehicle fuel, the production of ink and paints, and liquid alkanes are used as solvents and for the manufacture of methanol. They are also used as food preservatives and form the main constituent of natural gas. Alkenes are hydrocarbons that have a double bond as their functional group, making them unsaturated hydrocarbons. The general formula for alkenes is CnH2n, where N is the number of carbon atoms and 2n is the number of hydrogen atoms. For ethene, where N equals 2, the molecular formula is C2H4. This is the structure of ethene. For propene, with N equal to 3, the molecular formula is C3H6. This is the structure of propene. For butene, where N equals 4, the molecular formula is C4H8. This is the structure of butene. This slide again shows the molecular formula for butene, which is C4H8. This is the structure of butene. For pentene, with N equal to 5, the molecular formula is pentacarbon-decahydride.